Coolio. Just give me a minute. I think my mic is off. Just give me a minute here.
Cool. Wait, just give me a second here. And just do it here. Okay. Okay, audio is coming, I think. Uh, Let me just check. So, I. Cool. Let's check the audio. I'm not sure because the stream duration today would be actually really short. Okay, let me just have a look see here. Uh, okay, so it is working, but I'm sensing some interruption today. Give me a sec. Okay, I think it's good enough. It's within talking height. Problem is, this is okay. So, welcome to the seventh stream of Learn Rust with me, where, well, we'll be learning Rust with me. Well, I mean literally with me, because I am learning Rust on stream, so don't. And today we are going to do ownership. Okay. So we'll only do a little bit. This stream would actually be really short because I have to go somewhere tomorrow and really, really short. And well, I said I would do a stream on Monday, but due to some problems, actually, I wasn't able to stream. I just joined my new job. Actually, I had to verify some documents and stuff. So I, had to sit there. It had some problems, but you know, it's not that much of a deal for now. It was for me like yesterday, but today I have forgotten about it, kind of. So, well, we will do ownership a little bit, okay? Like, I'm not sure how much time I have, uh, and we won't be doing a lot because I have so much. Like, I have, you know, like some announcements to make, and well, we'll just continue for now. So, what is ownership? Okay. So, ownership is a set of rules that govern how a Rust program manages memory. All programs have to manage the way they use a computer's memory while running. Some languages have garbage collection that regularly looks for no longer used memory as the program runs. In other languages, the programmer must explicitly allocate shit. Yes, sorry, allocate and free the memory. Rust uses a third approach. Memory is managed through a system of ownership with a set of rules that the compiler checks. Okay. If any of the rules are violated, the program won't compile. None of the features of ownership will slow down your program while it's running. Okay. Because ownership is a new concept for many programmers, it does take some time to get used to, okay? The good news is that the more experienced you become with Rust and the rules of ownership system, the easier you will find it to naturally develop code that is safe and efficient. Keep at it. Cool. I, what happened? Sorry. I pressed this, I clicked this button. Show desktop. I don't need to see the desktop for now. So we'll just continue. Okay. So where? Okay. When you understand, when you understand ownership, you'll have a solid foundation of understanding the features that make Rust unique. Can you just give me a second? Give me a second. Uh, so I needed to test something. Okay, so the mouse was giving me a lot of problem actually. I need to check something first. Okay, it's working. We are good. So, uh, okay, when you understand ownership, you'll have a solid foundation for understanding the features that make Rust unique. In this chapter, you'll learn ownership by working through some examples that focus on a very common data structure, strings. Okay, the stack and the heap. Many programming languages don't require you to think about the stack and the heap very often, but in a systems programming language like Rust, whether a value is on the stack or the heap affects how the language behaves and why you have to make certain decisions. Parts of ownership will be described in relation to the stack and the heap in this chapter. So here is a brief explanation for in preparation. Both the stack and the heap are parts of memory available to your code to use at runtime, but they are structured in different ways. The stack stores value in the order it gets them and removes the values in the opposite order. Okay, this is referred to as last in first out. This is basically a basic stack. You know, if you have done data structures and algorithms, you will understand. I think it is explained below also. I'll have a look see though. So think of a stack of plates. When you add more plates, you put them on the top of the pile, and when you need a plate, you take one off the top. Yep. Adding or removing plates from the middle or bottom wouldn't work as well. Cool. Adding data is called pushing onto the stack, and removing data is called popping off the stack. Cool. All data stored on the stack must have a known fixed size. Data in an unknown size at compile time on or a size that might change must be stored in the heap instead. The heap is less organized. When you put data on the heap, you can request a certain amount of space. The memory allocator finds an empty slot in the heap that is big enough, marks it as being in use, and returns a pointer, which is the address of that location. This process is called allocating on the heap and is sometimes abbreviated as just allocating. Pushing values onto the stack is not considered allocating, okay? Because the pointer to the heap is a known fixed size, you can store the pointer on the stack. But when you want the actual data, you must follow the pointer. Yes. Think of being seated at a restaurant. When you enter, you state the number of people in your group, and the host finds an empty table that fits everyone and leads you there. If someone in your group comes late, they can ask where you've been seated to find you. Well, like the explanations are really neat here. Pushing onto the pushing to the stack is faster than allocating on the heap because the allocator never has to search for a place to store new data. That location is always at the top of the stack. Comparatively, allocating space onto the heap requires more work because the allocator must first find a big enough space to hold the data and then perform bookkeeping to prepare for the next allocation. Okay. It's a mouthful. Accessing data in the heap is slower than accessing data on the stack because you have to follow a pointer to get there. Contemporary processors are faster if they jump around less in memory. Okay, let me just check one thing. Okay, yeah, it's fine. So, okay, let's continue. Keeping okay, so here accessing data on the in the heap is slower than accessing data on the stack because you have to follow a pointer to get there. Contemporary processors are faster if they jump around less in memory. Continuing the analogy, uh, consider a server at a restaurant taking orders from many tables. It's most efficient to get all the orders at one table before moving on to the next table. Yes, taking an order from table A, then an order from table B, and then one from A again, then one from B again, which would be a much slower process. By the same token, a processor can do its job better if it works on data that's close to other data as it is on the stack rather than farther away as it can be on the heap. Okay. When your code calls a function, the values passed into the function, including potentially pointers to data on the heap, and functions local variables get pushed onto the stack. When the function is over, those values get popped off the stack. Okay. Keeping track of what parts of code are used, what data are using what data on the heap. So keeping track of what parts of code are using what data on the heap, minimizing the amount of duplicate data on the heap, and cleaning up unused data on the heap so you don't run out of space are all problems of the ownership addresses. Okay, once you understand ownership, you won't need to think about the stack and the heap very often. Cool. Just give me a second here. इसका message, ठीक है. चलो. You won't need to think about the stack and the heap very often. But knowing that main purpose of ownership is to manage heap data can help explain why it works the way it does. Okay, so we are good on that. I think there's too much on the left here. I need to position my mic better. See, normally, like even I have to look around, so I, remove my head from the mic. But okay, sorry. Okay, where we? Once you understand ownership, you won't need to think about the stack and the heap very often. But knowing the main purpose of ownership is to manage heap data can help explain why it works in the way it does. The way it does. Okay. So we will actually cover I think we are like I actually don't have that much time today. So and see, this concept is also very new to me. Owner, the concept of ownership. Okay, so I won't be actually adding much of my own to this part, since I am like this. This is the first time I've seen this. Okay, ownership rules. First, let's take a look at the ownership rules. Keep these rules in mind as we work through the example that illustrate them. Each value in Rust has a owner. Okay, there can be only one owner at a time. Okay, when the owner goes out of scope, the value will be dropped. Okay, so variable scope. Now that we are past basic Rust syntax, we won't include all the fn main code in the examples. So if you are following along, make sure to put the following examples inside a main function manually. Okay. So I think we should. Uh, just give me a second then. ज़्यादा ही rush हो- ज़्यादा mobile screen पर- Okay, so we I'll, I think we'll do I think we'll do it. Okay, we'll do it side by side. So first we'll read along for a while, not for a while, just till here. Okay. As a result, our examples will be a bit more concise, letting us focus on the actual details rather than boilerplate code. Exactly. Hmm. Not bad, huh? As a first example of ownership, we look at the scope of some variables. A scope is the range within a program for which an item is valid. Take the following variable. Yeah. Okay, it's becoming too comical now. Don't worry. Just having fun. Yeah. Okay. What what do I have to do is sorry if doing this. Okay. Uh, so basically telling me to. So this is our Fibonacci code. We did this last stream, I think. So, which was I think last stream was Learn Rust with me only. So this is basically wait. So actually, I did promise I'll do, you know, Senator Armstrong boss fight for Metal Gear, but well, the gaming part would have to be reduced. Like I might do Senator Armstrong tomorrow, but we'll discuss about that later. First, we'll do this. Let s equal to hello. Yes, put it here. Uh, like this. Okay. The variable s refers to a string literal, okay, where the value of the string is hard coded into the text of our program. Okay, yes, hello is hard coded now. The variable is valid from the point at which it's declared until the end of the current scope, which is these brackets actually, which are these brackets within the brackets. Okay. Listing for one shows a program with comments annotating where the variable s would be valid. See, so when it starts here, it won't be valid because it isn't declared yet. And here, you know, from here on forward till, so if I write any code, then S would be valid for anything below, the declaration until the end bracket. So after this, the S won't be valid because S is only valid within these brackets. So if you want to see an example, earlier we did this, our Fibonacci code. Like if I just show you, I think I do have main 2, right? Yes. Even here, I can show you an example here. So, I guess, so the scope of I guess, I can't access guess here. So sorry, I can't access guest here because it hasn't been declared yet. And from this point on, I can access guests until this end here, the end of the loop. So I can't access guests in my main function after the loop has ended, and or outside the loop. I can't access it if because I've declared it inside the loop. So the scope of guess is only inside the loop, basically. So this is scoping. I think how much time do I have? I'll finish by 12. Variable scope. So, okay. In other words, there are two important points from in time here. When S comes into scope, it is valid. It remains valid until it goes out of scope. So here I guess came into scope. Okay, this guess. From here on, it came into scope. And after this, see if I even write this, okay, print ln macro, not e print ln, sorry, print ln, and we'll just do, see, so what the see, cannot find value guess in this scope because it is not in this scope. It would throw an error. Even if I compile it, it would throw an error. So here in Rust Rover, at least it shows you the errors beforehand. Even if I put this also, then it's still an error because cannot find value guess in the scope. It's not in the scope. So this is the easiest example of scope I could give you. Uh, At this point, the relationship between scopes and when variables are valid is similar to that in other programming languages. Now we'll build on top of this understanding by introducing the string type. Sorry, I am actually in a bit of a hurry right now. So, like, forgive me if I did say the stream would be really short. So, because I have some things to tell you, we'll finish this by 11:55. Like, I'm really sorry if this stream is actually short because I have some things to say for 5 minutes actually. Like I did give a hint at like the starting of this stream. Okay, so like you'll have to bear with me till then. Um, the string type, right? To illustrate the rules of ownership, we need a data type that is more complex than those we covered in the data types section of chapter 3. Yes. Okay. The types covered previously are of a known size, can be stored on the stack and popped off the stack when the scope is over. Okay, and can be quickly and trivially copied to make a new independent instance if another part of code needs to use the same value in a different scope. Okay. But we want to look at data that is stored on the heap and explore how Rust knows when to clean up that data. And the string type is a great example. We'll concentrate on the parts of string that relate to ownership. These aspects also apply to other complex data types, whether they are provided by the standard library or created by you. Okay, I keep checking actually. Um, okay, sorry. We'll discuss string in more depth in chapter 8. Cool. We've already seen string literals, where a string value is hard coded into our program. String literals are convenient because they aren't suitable for every situation in which we may want to use text. Okay. One reason is that they are immutable. Okay. Another is not every string value can be known. Yes, when we write our code. For example, what if we take want to take user input and store it? See this one. What what if we want to take our user input and store it? Cool. Yep. For these situations, Rust has a second string type, capital S string. Okay. The string literal. So this is a string literal. Okay. And so this is the data type of string literal. Ampersand str. Okay. Can you just give me a second? Sorry. Okay. So, this type manages data allocated on the heap, as such and as such is able to store an amount of text that is unknown to us at compile time. Okay, yes. You can create a string from a string literal using the from function. Okay, string from. Okay. Hello. The double colon operator allows us to namespace this particular from function under the string type rather than using some sort of name like string underscore from. We'll discuss this syntax more in the method syntax section of chapter 5, and when we talk about namespacing with modules in the method syntax section of chapter sorry, and we'll talk about namespacing with modules and paths for referring an item in the module tree in chapter 7. This kind of string can be mutated. Cool. So let mut s equal to string from hello s dot push underscore str. Okay, world. So hello comma world. We'll actually try this. Okay. S dot push str Wait, what happened here? Oh, sorry. Give me a second here. There you go. And then we print. Cool. Run it. Hello world. There you go. So what's the difference here? Why can string be mutated into why can string be mutated but literals cannot? The difference is in how these two types deal with memory. Okay. So uh okay. Right now I will actually pause this stream here, like close this stream off here. Like I know we haven't covered much. Okay, and I have said that this stream would be really short. Okay, we have like because there is a lot to cover here. It would take me some time. I won't be able to stream for this long, not today, um, because actually, well, I have news. I have joined another like I have joined my new office. I have to go there tomorrow, and it's actually it's far away from here, and I'll have to reach early, and for that I'll have to leave very early. So in order to well, okay, let me just test one thing here. Sorry for breaking the thought here. Wait. Okay, live. And okay, my vest was showing up. Sorry. So my vest was showing up, and as I was saying, I have joined my new office, which is very far away from here. So, as of now, streaming would actually be a bit difficult for me. I will manage, but my streams have to be extremely short because, well, you know, the time it would take from, going from here to my office, then from my office back here, like the time alone would actually be a lot. So I might consider shifting from here. Well, I'll shift actually somewhere else, near close by to my office. So maybe like for this month, it's going to be a bit difficult. I might do a little bit less of gaming streams because gaming streams do take a lot of time for me. Uh, and like me, I will do the Senator Armstrong if I get some time tomorrow. I will stream Senator Armstrong boss fight. So otherwise, well, you like I would be streaming a lot less. You know, I did say last week that it might change. I might stream a lot less. So it is going to be a lot less. Like, I will try to stream every day, but I am not so sure. So, well, if and light bhi band ho gaya है. It happens. So, well, I'll be joining my new office, and well, I'll be meeting new people. Seeing a new place. Like it's not actually new to me. I've been there before, and by there I mean in that locality. But um, well, this would be the first time visiting, my new office, like where I'll work. new job. So, well, like it's a better paying job, obviously, but it would be more demanding like than the last one, way more demanding than the last one. Like I've heard times where I would have to stay back a lot, and it would be a bit difficult here. So since I didn't expect, the work conditions to be a bit different. Like I did, but not, you know, in the way that would, kind of harm my, like, affect my streaming. Not harm actually, but affect my, like streaming times, like my streaming schedule. Sorry. So it would like throw off my schedule for a while. I would actually have to stream a lot, you know, in a scheduled manner. Like normally, when I was streaming back then, I used to be like, okay, I'll stream whenever, but not back then. Like till now, okay. But well, from now on, there would be a set time actually, basically, because I won't actually have that much time to stream for now. So, well, and winter's over. Winter's over, like it's spring. It's lost. It's a lot less cold if you look at it that way. And spring is still fine, but I'm not prepared for summer. It gets too hot here. Like, so, well, actually, I'll cover this when I am not sure, because this week actually I would be streaming a lot less than before. So either I'll do Learn Rust with me, maybe I'll actually like have a look see around. I don't know. I don't have an idea. Um, but I'll figure it out. And you know, when I don't know when, how, why, but well, I'll manage, and maybe I'll be shifting to a new place. The rules there would be a bit different, and this setup might even get upgraded because, well, if I find a proper, streaming desk, like not a streaming desk, like just a normal work desk for like placing my laptop, and like I have the proper height, because right now the height is actually too short. So if I get a proper height desk when I'll shift away, then I would actually, uh, how do I say this? Like I would actually be able to stream properly. I'm also actually planning on buying new gear, because my current gear is actually busted. Okay, so and it's already been, I can't get warranty for this. It is, like you can hear the mic quality, it's not that good. Like it's okay, but there is some noise in between, so you can hear the noise basically. And well, sorry for blabbering on. I did blabber on a lot. But well, that's why yesterday I was really mad actually. I nearly wasted 2 days, just for the joining formalities. I'll be reporting to my new office tomorrow. So, workplace actually, not office. Yes, office, it's office, workplace, whatever. My new job. So, well, till then, not till then. Well, tomorrow I will stream. Maybe Senator Armstrong, if I, or I could just continue Learn Rust with me. like whatever floats my boat. So, well, thank you guys for watching. It's already 12 o'clock and I have to leave. So sorry for this short stream. But if you have watched till here, but I know nobody's watching since I haven't been streaming for a few days now. So, well, thank you for watching.